Hi, my name is Claire. I am a Bachelor of Arts third year and I study philosophy and psychology. And today we're talking about psychology, and I will throw in a bit of philosophy at the end to appease myself, basically. You can't have it without that. So, in psychology, Zach asked me to talk about my most favourite bit in psychology, and it's neuropsychology, actually, how the brain works in relation to social side and all of that. I found it very interesting. So it kind of continues the theme from last week. We were talking about robot brains. Well, today I'm going to argue that we can't have robot brains. Our brain is way too organic. And the way we can demonstrate this is through synesthesia. So if anyone has heard of synesthesia, it's a crossover of senses. And we'll talk about that in a minute. So next slide. Can you click on Ratatouille? This is an example of synesthesia.
Wrong button.
So, if you can hear him.
Still was right. Oh, yeah. Amazing. Each flavor was totally unique. But combine one flavor with another, and something new was created.
Okay, so synesthesia, the crossover of senses. As you can see, Ratatouille, he had a crossover of quite a few senses. He was a dual sensory synesthete. He had a crossover between taste, sound, and vision. So with synesthesia is you literally see, taste, smell things that aren't there in relation to when you feel another sense. So the most common type of synesthesia is when you can see voices. I know two synesthetes myself. One of them can see a thin tape of colour whenever someone talks, and each individual has a different colour. And I know another person who can see like an aura surrounding the face when the people talk, and everyone has a different colour. So it's very interesting, so next slide. The most interesting thing about it is that it arises because the brain is plastic, and I don't know if you've heard this term, but the idea is that the brain is made up of a bunch of neurons. All the neurons wire together, but it can change in response to sensory stimulation. So in these sort of deprivation studies that we're looking at here, what they did was they got some cats, they covered their eye from birth, and then they found that when they took the patch off, the cats still couldn't see. Because what had happened is that the brain had covered over that space, the visual cortex, with another sense or another process. So they'd lost, they could still see, but they just couldn't process it. The brain just could not recognise sight anymore. And so you can see here that's normal, so they've got an equal deprivation. When they got rid of, they sutured their eyes closed. That's another thing about psychology. It's a little unethical, but we'll move on to that at a different time. And you can see that monocular deprivation meant that they could only see out of one eye, but then in the adult, it didn't do it so much. So you can see both that the brain will change, and particularly during childhood, during development. This is why we have the theory of languages. When we learn languages, we adapt to our own language, and we cannot learn another language as well as we have learned our native tongue, because the brain will change. The brain will become specialised towards our language. They'll become specialised towards our sensory input. So the idea with synesthesia is that these areas of the brain become overlapped because the brain is so plastic, because it can change. So I think that this condition is actually very amazing, and I personally would like it a lot. I'd love to be able to see colours. I know synesthetes who can see music, for example, but I want to test whether any of you are synesthetes, or whether we are all synesthetes. So I know we don't have any paper or anything, but we're going to conduct an experiment because I am totally a legit scientist, psychologist. I want you to think of the first colour that pops into your head when I say the following letters, okay? So when I say the letter A, what's the first colour you think of? Shout them out.
Orange.
Orange.
Amber.
Amber, yeah, good. X.
Blue.
Black.
G.
Green.
O.
Orange.
Alright, so for A, X and G, you have all just demonstrated a reproduced experimental result. They reproduced this same result where A is orange or red, X is black or blue, and G is always green in multiple studies. So what does that mean? The implication here is that the normal population seems to have some innate bias for colours and graphemes, which is the letters, just like some synesthetes. It's exactly the same.
Does that is that cross-cultural?
Yes. And we'll come to another cross-cultural study as well, which is really interesting. Okay, so next slide. So there are two theories about how this might have come about, and it has to do with developmental theories and then top-down processing theories. The first one is cross-activation, and the idea is that synesthetes have an excessive amount of connections. So when they're developing, the brain is plastic, and so they've developed all these connections, and they're just not pruned away over time, which is normal for development. So, for example, activation in one part of the infant brain tends to cause unrelated sensory experiences in other brains, and they've shown this using fMRI, which is functional magnetic resonance imaging, where they can see where it is lighting up over time. So, for example, in babies, spoken language will give a result over the visual cortex, which seems really strange because you're speaking something but it's lighting up over the vision. Face processing will also activate areas of language. So it just demonstrates, I think, how important language processing is in terms of both facial features and spoken features for developing children. Because we all know how important body language is. It is literally body language. You are viewing a language in your brain. Another example of cross-activation theory is with disabled people. So they use different parts of their brain for normal sensory processing. You might have heard the idea of blind people having an amazing sense of hearing or sense of smell, which is less common. But it is true that the visual area in blind will become activated in response to auditory input. So it's not that they have better sensory hearing, it's that their brain has given more area to that sense because it's being used. So a feature of the normal brain, that is plasticity, can result in undifferentiated sensory experience as part of normal development and as part of adapting to an environment as an adult. And then the inhibition model. So this is where we still have the connections. The idea here is that the connections aren't pruned away, they're just repressed by top-down processes from the prefrontal cortex, which is responsible for our consciousness, our higher order thinking, and things like that. So the idea here is that the plastic brain is not pruned but inhibited, and synesthetes connections are disinhibited. So the connections are there, they're just actually using them, whereas we don't use them. And there's a couple of examples of how this theory came about. One is, of course, drugs. When you're on mind-altering drugs, the idea is that your top-down process of consciousness and the inhibitory models will be relaxed, and you'll start to see things and process things cross-sensorily, like a synesthete. Another example is in deprivation studies, which is not like cats. They don't do the same thing they do for cats on humans, which is great. But what they do is they deprive normal humans of one sense, but it will actually increase the abilities of other modalities for a very short space of time. So what they did was, in one study, sighted adults were blindfolded for just 5 days, and it was found that this resulted in increased activation of the visual cortex for tactile stimulation. So that meant that their ability to distinguish tactile patterns was increased. Their sense of touch had replaced the visual cortex areas of the brain. This was shown even in fMRI studies, and as in blind adults, it was shown that their ability to discriminate tactile sensations was actually decreased when they inhibited the visual cortex. So during that 5 days where they were blind, they actually responded as blind people would to other sensory sensations. So that was really interesting. Yes, and the next one. So we can wonder here about whether synesthesia is a condition, or is it just another natural part of the developing brain? And it seems so, because we know that we often process senses together cross-modally. So in optical illusions, we can see that we need depth cues, visual cues. We need a certain amount of stimulation before we can perceive that as an image. It's not real, it's an image, but we need to do that as a cross-modal perception rather than just one perception itself. Next one. Okay. So this implies that we could learn to be synesthetes, which is kind of cool. Unfortunately not true, but it is kind of cool. But consider, for example, our tendency to associate letters with colours. That has been shown cross-culturally and across time. And to a certain extent, it is dependent on the way we learn to read and write. So I don't know how many of you have learnt the days of the month, the days of the month, the months of the year, like this. Were they coloured? Were your numbers coloured when you were a child? Did it make it easy to remember? Do you often colour your notes now? All this cross-modal activation is really important for learning because it enhances the plasticity of our brains and forms more and more connections. So you can see here some of the different ways that synesthesia manifests. So over here, letters and numbers are a particular colour, and it's really interesting because synesthetes will consistently say which colour is their letter and vice versa. They never get tricked like you would think if it was a trick. Other people, which is a really interesting one actually, they will see the year in a circle, a visual, not a hallucination, but a visual manifestation of time in a circle. And it's very strange, I don't quite understand this one. So they get their temporal sense and their visual sense mixed up. It's very strange. Another really strange one is the proprioceptive and the tactile synesthetes. So proprioceptive is your sense of self, pain, all of that. They will be able to feel pain when something else is touched. And that would be terrible synesthesia to have. But it's very interesting. Yeah, and they can solve questions. If they have the one where the numbers correspond to colours, then they can solve these very easily. And on the next slide, I'll just show you. This is a way of picking synesthetes. They will have a faster response time for this slide than a normal population because they'll be able to see the colours. So for example, one synesthete sees S's as greens, or no, 5's as greens and S's as reds. Yeah, that's okay. So they'll be able to pick out how many red ones there are here really quickly, unlike us. Or me, you can't even tell the difference. So, yeah, that's really interesting. Okay, next. Okay, so, as much as it's dependent upon learning, there are some normal cross-modal associations that seem to defy our logical explanations of them. So, we're going to do another experiment, and hopefully, if anyone can hear it, everyone needs to hear this for it to work. So I'm going to play a clip of two bouncing balls. Each of the balls is making a sound. And the clip is going to ask you which ball is making one of the sounds. And we'll see which one you pick. So we'll see if we can do it. I put it up on the thing and then do that. Would you like it again? Or are we right? Again? Again. Okay.
That.
Nope.
Nope.
Go away, Java.
There you go. Okay. 2 votes for the white ball. 2 votes for the dark ball. So the majority of you voted for the white ball, and that is a very reliable, consistent result. They usually do it on children, actually, to test whether they have synesthesia. But the problem is, of course, that that result comes up all the time. But why? Why do we associate high pitches with light, with lightness? And why do we associate dark pitches with low light, with darkness? There's heaps of other examples. So if we go to the next one. So there's pitch lightness, which is one we just demonstrated ourselves. Colour letters, which we have also demonstrated ourselves. We are excellent experimental subjects. I'm very excited. Taste and smell would not be the same, one without the other. How do we really distinguish taste and smell? Languages, sounds and shapes, O's, around, B's, all the phonetics are thought to be associated with this cross-modal processing. And then this is a really interesting thing. So the Buba-Kiki effect. So across cultures, across languages, people will recognise Buba and Kiki. Which one do you think sounds round? Buba. And Kiki sounds sharp, spiky. Multiple cultures, I think they've tested it on something like 66 different languages, will make that same distinction between Buba and Kiki. And they can't explain it, not really. So you could even argue that these sort of cultural manifestations of human condition are reliant on cross-modal associations that we have in our brains. So in the next one, in this experiment, I'm sure everyone has done this, making art to music when they were little. Ever put on a, no, the deprived children. It's okay. But what they did in this experiment was they played some music, different pieces of music, and they let kids just kind of do whatever they want, and they looked at the ways that they manifested this experience, and you can see certain similarities in there. But so far from being confounded by our learning, you could argue that this cross-modal processing might enhance our learning experience. So that's why we do highlighting, it's why we do art and things like that. It might encourage creativity by encouraging these connections within our brains. And I'm just going to mention Freud because no psychology presentation is complete without mentioning Freud, at least in part. We all know about Freudian associations, the Oedipus complex and the anal stage, things like that. To a lot of people, these sort of theories have made a lot of sense. And why have they made sense? Because they seem to activate different senses within ourselves. Is it possible, maybe, that we make logical associations and assumptions based on these ways that our brains have been cross-modally associated, as in art, as in creativity, as in optical illusions, and things like that? And then you can consider it in terms of philosophy, because now I've come full circle. Does synesthesia indicate our subjective experiences are really, really subjective? Like, we can't tell when someone's looking at red because ours, the idea is when someone looks at red, we call it red, but it might be different. We call it green, it's actually green. But what if actually it is actually really, really similar? What if by calling it that name, we are also just seeing it as that colour? Because our brain has processed the word means a certain thing, and our perception has been altered by the way of our learning. So that's all I've got to say.
So, questions?
Yeah.
Hi. When you discussed adults who've been blindfolded for 5 days and who had a better sense of touch as a result of tactile senses, when those adults were actually, that had their blindfolds removed, was their vision worse than it would have been previously, since this space had been devoted to tactile sense instead?
Yes, it had been. Yes, and it took, I don't know how long it took to go back to normal, but the important thing is that it did go back to normal. So just as the brain changed in result of being deprived, it did go back to being normal. Interestingly, I think that if they had done it on children, on human children, you would have had the same result as the cats. They would have had permanent blindness, and that's actually part of the problem with things like stigmatisms and things like that is that you know how some kids, they wore the eye patch? Yeah, it's poor children. It was because they were trying to, that it wasn't actually covering the injured eye. Those patches covered the uninjured eye because they wanted to make sure that the level of sensory stimulation of the two visual cortexes was the same, so that it didn't turn out to be thinking that it was deprived and would rewire that section to another sense. So that's why they covered the eyes. Yeah.
I wore one of those.
Did you?
That thing of vision coming back in adults,
Yeah.
is that akin to people relearning skills incredibly quickly? So even if, especially physical skills, if someone knew a skill at one point, they then don't use that skill for years and years and years, but if they come back to it, they pick it up incredibly quickly.
Like learning to ride a bike?
Like learning to ride a bike, I was going to say. I'm not sure, but learning to ride a bike is part of a different thing that's working within the brain as well, which is called procedural memory. So in the long-term memory, so you have short-term and long-term memory. In long-term memory, you have different sets of memories, and one of those is procedural memory, where your brain will remember how to actually do physical movements rather than remembering events or places or things. So I reckon it would have more to do with procedural memory than with the somatosensory cortex, which is more about what this is about. It can also do with mirror neurons. I haven't mentioned mirror neurons. Mirror neurons are pretty cool. They're the neurons in the brain that when you see something moving, your mirror neurons will fire before you even move. Oh. Is that a power out?
Nope,
No?
that was it deciding it was going to sleep.
Oh, okay. Yeah, so mirror neurons in the brain will respond to a stimuli before you've even thought about it. And they thought that mirror neurons, so when you see someone picking up a spoon, the same neurons that would fire for when you pick up a spoon will fire even though you haven't done anything. And mirror neurons are really interesting. I can do a whole thing about mirror neurons. Mirror neurons are interesting because they think that they have something to do with empathy. So when you see someone doing something else, these mirror neurons will fire and create a similar response in your own brain. And so they think that might be the basis of a lot of empathic responses. Yeah.
More of a quick comment. Even the words booba and kiki, booba is just all round shapes and kiki is all angular shapes. Do you think that's probably got something to do with it, or?
Well, the shapes of the words are called graphemes.
Yeah.
And so that is definitely true. They do look sharp and they do look round. But how do we make up those graphemes in the first place? The shape of the words, the actual writing of them.
And are those the graphemes in different languages similarly round and sharp?
I don't know. No, I don't think so. This particular study that I'm referencing is just to do with the sounds. So they sound sharp, they sound round. They don't have the same words for them, but that would be interesting. But you can definitely see the relationship between the grapheme itself and the sound. Yeah.
Okay, I think we might call it. Thank you very much.
That's all right. Thank you.